So now in order to convert this downloaded model that we have already downloaded here, what we have to do is now again look at the repo that we already cloned from the Yolo 4 repository from the AI guys code. And here if we see in the save model.py, there is only one function called save.tf, and basically what it is doing, it is loading the .weight files, and based on some parameters that we already have discussed earlier, it converts the input .weights file into a .pv file that we can use for inferencing. And if we go up, we see like it has used quite a few functions from a directory called core. So it becomes easier for us, because how our web service is being designed is also including a core directory that we can use to save those core functionalities of YOLO in this core package. So basically we can copy all these functionalities that we have here into this new package. As we discussed, if you can see now, we have a new directory called YOLO under image detection code, and it has all the files and the functionalities that was previously being used here. We also noticed that there were some run command line arguments that or parameters that we need in order to check what kind of model we have to convert, where we want to save our converted model and stuff. So for that, how we did it is basically under this image detection code, we have a constants.dat file, and in this constants what we have done is just put in all those parameters that we need to convert the model, and for them we have put the default values. For now, like I have kept the values as it is, as they were here, and basically for the download weight path, for the final weight path, I have given the paths that I want to store my converted model and from where I want to pick up the model. And if you see, this is exactly the same as this path. So from where this will read, and these are all the class files and stuff that it needs to read. For that reason, we also have to put the data folder that is basically this one into our etc directory, and we are not gonna put all the folders because we don't need these images and videos to pack. But what we'll do, we'll copy this data folder and maybe in etc add image detection service. We'll just paste this data. So basically what we can do, the easiest way to do it is copy this data folder from here and then just paste it here. And as I said earlier, we don't need this. And now basically this is the Yolo 4 model. Basically if you see now, it can read all these data files in So yes, this is what it is, and this save model.py is also under now the image detection core. And what it does, I have already created a model converter class that basically initializes all the parameter values that was basically needed here, and then with this, from that class I replicated this save.tf as a class function, that is a model converter.save.tf. And from here what we do is do the same thing that was being done in the Yolo repository, and how we want to incorporate it is now in the models provider we want to pass it. So basically what we'll do, we'll pass another object and we'll initialize that model converter object here that we're getting here. Nice. And once the model has been downloaded, we want to convert the model in models provider. And what we also have to do is from where model provider was getting initialized, that is in app.py, what we have to do here, along with passing the config, now what we will do is first import the model converter, and once we have the model converter we can initialize the model converter and then pass this model converter to model provider. The reason we do this is we don't want the model provider that is basically in the foundation package, we don't want any dependency in the foundation package. So basically we want the foundation package to be as independent as it can from any other packages that it uses. So what we did in the service package, where we have this app.py, there we initialize the model converter that is basically in this core package now. So basically service can have dependencies on core, core can dependencies on other packages, but while it comes to the foundation package, we want it to be as independent as it can be, because the main aim is it can be used by multiple services to do some similar common functions. So that is why we did this. And yes, now if we run it once again, then we can see what it is doing. And basically if we run it again, so here we come to model converter, and in the model converter it basically gets all the parameter values from, and mostly these parameter values are read from the config file that is here. And if the config files, it cannot find any of the parameters in the config file. So at that time it will go to this image detection core, and where they have the constants, and they will read it from this constants file, and this is what you are seeing now. And basically once the model converter is initialized, so now you can see there is a model converter object we have, which can convert any model. So it has its output directory set, it has its input directory set, and all the other parameters it needs to convert the model. And then we go to model provider.download model, and there it checks if the model has been downloaded, and as the model was already existing, it directly went to model convert.save.tf. And if you see in the console, what it is doing is now converting the input model, that is the .weights file, into a .pb file. And it is the model summary that it has printed 64 million parameters here. And if we go to convert save.tf, what we see here, it printed out the model summary, and now it is saving the model to the output file that we have. And this is the thing in the logs. And what we can do now is go and check if it actually is converting the model. So basically, if we see the output path now here in models, it still is working in the conversion. It takes some time. Mostly the model is 250 MB approx big, so it takes a bit of time at first to convert the model and save it to the location. But what also save.model.py does, it checks if already the converted model is there in the output directory or not, and if it is not, then only it does all the conversions and stuff. And we can once check now, and if you can see, it has converted the model successfully, and now the model is up and running. And if we check here now, there is a yellow checkpoint, and there you can see the saved model.pb that will be used for our inferencing. So what we have done right now is we already have a web service that downloads a given Yolo version 4 model from the cloud, and then saves it to the desired format. And in the next part, what we are gonna see is how to write a method or an endpoint that can actually use this model to detect objects and do inferencing on images.